Oops, I hit the wrong button. All right. So, area formulas. Now, for our area formulas, we're talking mostly about area of polygons. However, I'm going to include some at the end that are not polygons. I'm also going to include a couple formulas at the very end that are not area formulas. But for the majority, this is all of our area formulas. So, the first one that we need to do is area of a regular polygon. We learned this one yesterday. Regular polygon. Now, you can draw whatever regular polygon you want. I'm going to go with a pentagon just because I think I can draw it fairly well. So, yeah, it goes all the way down. We're probably even going to have to go on to the back of the paper. It's going to be a few things. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 sections. Yeah. Like I said, there's a lot. So, we did this one yesterday, and there was a couple parts that we needed to know. So, I'm going to go ahead and list these different pieces that we should know over here off to the side for this one. We need to know what A, S, N, and capital P stand for when we do this one. So A is going to stand for our apothem, which if you're trying to spell it, I'd say apothem, but correct pronunciation is apothem. So we have our apothem is the distance from the center to the side of our polygon. So that's our apothem. Kind of looks like a radius. Then we have S is for the length of one side. Length of side. And that's why we're using this. N stands for the number of sides. Number of sides. Thank you. Capital P stands for the perimeter. So on this figure, things that you need to have labeled, you should have A labeled. You should also have one of your sides labeled as S. It doesn't matter which side. You can label any of them as S because it's the length of one side, and this is a regular polygon, so they're all the same length.
Is the apothem always going to be given to you?
It will not always be given to you. All right. So, the formulas that you have to know for this one, area equals either 1/2. Anybody remember the formula from yesterday?
Equals 1/2 base times height.
A, S, N. So 1/2 the apothem times the length of one side times the number of sides. The other way that you can write this is 1/2 AP, because you can replace S times N with the perimeter, because in a regular polygon, you can find the perimeter by doing the length of one side times the number of sides. So that's our first set. Now, we also need to know area of a triangle, which again, this is one that should be familiar. But there's two different formulas for area of a triangle that we need to know. So the first one is the one that we should already be familiar with. So triangle given base and height. So this is going to be the formula for area of a triangle if you're given the base and the height. Now, I am going to draw this several different ways. I'm going to actually draw 4 small figures here. But they all include base and height. Where B is our base and H is our height. If you don't want to draw all 4, you don't have to. You might want to see what I draw and then pick and choose. Alright? So, first one I'm going to draw is a right triangle. Then I'm going to draw one that looks like an acute triangle. And then I'm going to draw two obtuse triangles where the top vertex is not directly over the base. So, the first one's easy. Again, anytime we talk about base and height, they have to be perpendicular lengths. So, if they give you a right triangle, they give you the two legs. One would be the base, one would be the height. If they gave you an acute triangle, normally they would give you one side as the base, and then the height, again, is the same thing as, the height is essentially the length of the altitude, right? So, drawing an altitude, and that would be our height that we'd have to use. For these two figures, now, if the bottom was still the base, then the height on this figure would be where? You'd have to extend the base and be on the outside of the figure. So the height would be out here. Now, just because they call it the base doesn't mean it has to be on the bottom. So if they gave you this side could be our base. If they gave you that side as the base, then the height would be, again, the perpendicular distance to the opposite vertex. Now, no matter which one of these they do, the formula is always the same. 1/2 base times height. I will always use that form of the equation. Now, some of you guys may have learned it another way. I'm fine with you using the other way, which is area equals base over height divided by 2. Whether you say 1/2 base times height or you say base times height divided by 2, it's the same thing. I will never use this whenever I solve a problem, though. So anytime we go over anything in class, I'll always use the first one. Now, there is a second formula for triangles. The big A is just area, yeah. Capital A stands for area. Yeah, I forgot to say that at the beginning. Thank you. So, all of these, capital A is standing for areas. So these are all area formulas. All right, now, there's a second way of finding area of a triangle. So, we're going to do triangle again.
So, for the triangle, would you do the base times the height and then times the half, or like 1/2 times the base and then times the height? Like, I'm so confused.
So, when you do when you do 1/2 base times height, you can either say, it doesn't matter which ones you multiply first. So, you can either do 1/2 the base and then times the height. You could do 1/2 the height and then times the base. You could do base times height and then times it by 1/2. Again, you're multiplying. So, it doesn't matter what order you're multiplying, but you're only multiplying it once. One of the most common mistakes here is a lot of times people try to distribute that 1/2 to both values. It doesn't get distributed. There's no plus sign in between base and height, right? Again, it's just 1/2 times base and height. So it doesn't matter which value you multiply by 1/2, whether you multiply. So it's not, you don't multiply by 1/2 twice, because then that'd be a fourth, right? So either multiply your two numbers first and then times it by half, or multiply one of the two values separately by half and then multiply it by the other one. It doesn't matter which way you do it. So now, the other method, a triangle, if you're given side angle side, meaning you have two sides and included angle. Now, this uses a little bit of trig. Now, it's not anything where you actually have to solve anything, like for a missing side, but there is a trig function in our actual equation. So, I'm going to draw a triangle just like when we had our trig section with vertices A, B, and C. So here's A, here's B, here's C. All capital letters at the vertexes, or vertices. Then the sides are labeled with lowercase a, b, and c across from them. So that's A, this is lowercase a. That's B, this is lowercase b. That's C, this is lowercase c. Now, our Springboard book only writes this one way. The equation is going to be area is equal to 1/2. And what they're saying we're being given is this angle A and these two sides. So we have two sides and included angle. So it's going to be B times C times sine of A. Again, there's nothing like you have to solve for. It's not like we're solving for a missing side using our trig and then plugging it into a formula. It's just part of our formula here. So you'll be given those three pieces. You'll be told two sides and an angle, and you're just plugging it into this equation. So you just type it into the calculator. Now, there are a couple of other ways that you can actually write this one. So I'm going to write them out, the other two ways. If you don't want to write the other two, that's fine. But depending on which angle they give us, you could rearrange these letters. So for example, if we're given these three pieces instead, then it would be 1/2 AC sine of B. If they gave you the top one, so those three on top, it would be 1/2 AB sine of C. No matter how you write that equation, it means the same thing. You have two sides and the included angle. That's why the two sides are lowercase, and then the angle is always the other one. It's not one of the two letters that's already been used. It's because it's the one that's between the two sides. So again, you can just write it the first way, or if you want to write all three, that's fine. But the idea here is you're going to have two sides and an included angle, and you use those three parts in your equation. And we're not focusing a lot on that today. We'll do a lot more examples with that probably tomorrow. But again, you at least need to know the equation for now. All right, the next one that we need to talk about is a rectangle, which is probably the one that's most familiar to all you guys. Now, yep, that is it, what you just said, base times height. Now, again, in earlier years, you probably learned it as length times width. Again, that's fine. It's the same thing as saying base times height. So, here we have a rectangle. Does it matter which side you call base and which side you call height? No, not as long as they're perpendicular to one another, right? So, if this is base, I could use either of those sides as height. Now, for the equation, simply area equals base times height. That's it for that one. Of all the formulas, you guys should definitely already know that one. Well, the next one's just as easy. Parallelogram. Anybody know the formula for a parallelogram?
It's like it has something to do with
It's as easy as the last one. It's just base times height.
Oh well.
Oh yeah, where you four sides?
So I'm going to draw three different figures because it can be given to you different ways. But again, a rectangle falls under the category of parallelogram. That's why the formula is the same. So I'm going to show three different setups because they can show this a couple different ways. So I'm just drawing the same parallelogram a couple times here. Yeah. Like I said, there's 11 sections, so alright. So the problem with all parallelograms that aren't rectangles is the sides are not perpendicular. So you can't use two sides as the base and the height if it's not a rectangle. So on here, if the bottom is the base, then the height is the perpendicular distance to the other side. If you said, you could also say, instead of writing it inside, sometimes they'll give you the height on the outside. The other way that they could give it to you, sometimes instead of giving you the bottom measure, or even the top measure for that fact, they might give you on the two sides. So let's say they called this one the base, because again, base doesn't have to be on bottom. Then we're looking at the perpendicular distance between those sides. So again, the perpendicular distance between those two sides. If they gave you this side, then you'd have to use that length as your height.
Are these always going to be given to you? You have to find them elsewhere.
Most of the time they'll be given to you. However, you see all the right angles in here?
Yeah, no.
If I drew one of these, say this height, if I put it right at one of the vertices, then I'd form a right triangle. So is it possible that they might give us some other information in order to solve for the height first? Yeah. Again, we might have like Pythagorean theorem. Again, it's going to happen. All right.
It's just alien.
Now, the next one has two formulas. So rhombus or plural rhombi. That's actually correct. Rhombuses is actually acceptable as well. It just sounds wrong. So now, on this one, well, a rhombus falls under the category of what? Parallelogram. So you could use base times height again.
Is that a slash or is that you messing up on the beat?
No, that was a slash. Rhombus or rhombi. That was my or slash.
You just really messed up that name.
That'd be an extreme mess up.
That would be my
I drew the slash way before I had the B there.
disgusting. Then why would you line it up like that? First
It just happened.
Exactly.
Alright, anyway. Moving on. We have. So I'm going to draw two rhombi. And again, you want to try to draw it so that the sides are equal, because that's what makes it a rhombus, right? So it's a little challenging to do, but try to draw them as equal looking as possible. So again, just like on the last one, we could have the base and height. Let me try and draw this again. Now, the other method doesn't use the base and height at all. The other method uses the diagonals. So we have two diagonals in a rhombus. One going across this way, one going across this way. The important thing here is that in a rhombus, the diagonals are perpendicular.
Oh my god, it forms a triangle.
Notice again, yeah, it forms a triangle. So,
Right triangle.
just like on all of our other shapes, where we're using base and height, because base and height are perpendicular to each other, in a rhombus, the diagonals are perpendicular to each other. So we get to use those to find area. And we get to use them because we can form triangles, and they would act as the bases and heights of the triangle. So our formula here is very similar to our formula for a triangle, except for instead of base and height, we have the two diagonals. So we'll have area equals 1/2 diagonal 1 times diagonal 2. Now if you're trying to label your figure with the diagonal, it might be easiest to do with the little braces.
Minus or plus or times or something?
Times. So again, diagonal 1 and diagonal 2, the lengths of those two diagonals.
Okay, just making sure. Mr. Spizak, the paper you gave me is bad. I stole paper from you, and you can see the lines of the graph paper through the dark pen. And I am concerned.
Maybe it's your pen that's magic.
They're your pens!
All right, kite. Now, for a kite does not have any sides that are perpendicular. What does a kite have that is perpendicular?
Oh, it had that little cross thing. Oh no.
Which are the diagonals. So guess what the formula for a kite's going to be?
Diagonal 1, diagonal 2.
The same as the second formula for a rhombus. So, now again, when I draw my kite, I prefer drawing the diagonals first to help me line it up. Yes, what's your question? I guess. So, again, we have diagonal 1. Doesn't matter which one you call diagonal 1 or diagonal 2. But again, there are two diagonals. So D1, D2. And it's the same formula that we had before. Here equals 1/2. Diagonal 1 times diagonal 2. Now, again, you don't have to. I know on the last two, I drew the dot for my multiplication symbol between them. You don't have to draw the multiplication symbol there because you have two variables next to each other. So again, you could do it just like we did for all the other ones. For some reason in most books, when they have a subscript number, they tend to write a multiplication symbol after. I don't know why. Don't have a good reason there. Alright. I think we're going to have to go on. Well, I'm going to have to go on to another sheet of paper. So, again, if you have enough room on your paper, great. Keep going. But we have, let's see, 1, 2, 3, 4 more sections.
Is this enough room for the next one?
Oh, that'd be enough room for a trapezoid, and then you can do the other ones in the back. So you could fit all your polygons on one side. So we have one more. We have one more polygon.
Yeah, that's what I meant. I just meant the next thing. Not all of them.
Yeah. We have one more polygon. So let me continue this on. Yeah, I'm creating a new paper. That's why I'm doing my headers over again. All right. So the last, guys. All right. The last polygon is a trapezoid that we're going to have a formula for. Ladies and gents.
Do we determine the letter Q in any of these?
Okay, so our diagram here is of a trapezoid. You can draw it of a isosceles trapezoid or any trapezoid. It doesn't have to be anything specific. Now, for a trapezoid, how many bases do we have? Two. We have the base on top and the base on bottom. Because remember, the two that are parallel to each other are referred to as the bases. So we have B1 and B2. The distance between those, the perpendicular distance between them, will be our height. So now, does anybody know the formula for a trapezoid?
Base 1.
Oh, base.
It's base 2 minus base 1. That by 2.
You're close. So, essentially what we are doing is we're taking the average of our bases and then multiplying it by the height. So, the way it's written in most books is actually 1/2 B1 plus B2 times height. So, if I don't write the height there, that's essentially the average of my two bases. And then we're multiplying by the height. Some books actually write it so that you have B1 plus B2 over 2 and then times the height. Again, there's several different ways you can write that equation and be correct.
That makes a little bit more sense.
So again, it's the average of your two bases and then times the height. some books put the height in front of the parentheses, which doesn't make any sense to me. But
It's like just write it all over.
you could write it all over too as well. That would also be correct. All right. Now there are three other shapes. I guess we'll be talking about. So the first one is a circle.
Ew.
So this is not a polygon, but again. So we have our circle. The only measure we need, guys, the only measure we need in order to do area of a circle is our radius. And it is pi r squared. So our formula for area is pi r squared. Now, since we're talking about circles, I also want to go ahead and put another formula over here. So that's our area formula. There's another formula that comes in handy when we do circles. Well, we don't call it perimeter, we call it circumference. So distance around a circle is our circumference. So that formula is either 2 pi r or diameter times pi. Both work because 2 times r would give us the diameter. Now, where? Here? That's an R for radius. Okay. Then we have sector.
Sorry, what?
Sector. A sector is also dealing with a circle. What's a sector look like?
A sector looks like
Well, it looks like a triangle in a circle, right?
Kind of, yeah. It's like a slice of pizza. Alright.
just cut wrong. Oh wait, I thought it was.
So a sector is outlined by 2 radii and an arc. So there's 2 things that you really need in order to find the area of a sector. So again, what we're finding here is the area of this sector.
What is that? M what?
Oh, it's triangle.
M for measure. Again, when we have a arc, we talk about in terms of measure in degrees, right? A full circle is 360 degrees. And so this one is representing our measure of that arc. That's what the M's for. Now, this area is part of a circle, right? So we're still technically using this formula. All we're doing is taking that formula and multiplying it by the fraction of the circle that we're using. So we have area, and then it's going to be equal to the fraction, so I'm going to put a fraction bar, times pi r squared, which would be the full area of the circle. But we don't want the full area of the circle, we just want that little section, right? Well, we know the full circle is how many degrees? 360. So 360 goes on bottom, and then the measure of the piece we're using goes on top. Again, I'm using the degree symbol because our measure is in degrees. Towards the end of this chapter, we will also talk about radians just a little bit. So that other measure that's on your calculator. But again, everything that we're doing right now is in degrees. No, one more thing. All right. So now this last one that we're going to do gets away from area altogether. It's still dealing with a circle.
No!
This one's going to be arc length. Now, for this one, again, if we are looking for the length of this section, we're again going to have to be given the measure of the arc, or same way that I gave the measure out there, I could have also done it with my central angle that we had before. So I'm going to put M in here this time. And now again, this length is found by doing something similar to what we just did in the last one. But now, are we dealing with area at all in this one? No. So, this arc length is part of the overall what of the circle? It's part of our circumference. So, this time, instead of saying a fraction of the area, we're doing a fraction of the circumference. So, it starts off the same way. Same fraction that we had in the last one. M degrees out of 360 times our circumference formula. And you could use either circumference formula. I'm just going to use the 2 pi r. That is our last one. So, again, I know that's a lot of formulas. Our homework tonight is going to focus mainly on the polygons. I'm going to write the homework down here. Now, the homework is a little bit long, so I'm making it worth a total of 8 points out of 4 points, meaning there's some extra credit. So if you get the entire assignment done, it's like worth double. If you get half of it done, you'll still get full credit. So, like I said, it's a little bit longer of an assignment, so it's worth extra. Alright? Again, it's going to be out of 4, but you can get up to 8 points on it. So it's like having 2 assignment grades for 1. So, if you missed an assignment recently, then it's like it's replacing that 0.
So if we don't do it, will we have 0 out of 8 or 0 out of 4?
It'll be 0 out of 4. So if you don't do it, it's still like you only missed out on 1 assignment grade. But if you do the whole thing, it's like you get that extra assignment.
Basically, it's required to do half.